It's crazy. They grow up so fast. All right, here we go. We're going to have to do a big equation. And it is going to be one of these big ones. Okay? Now, I have no question in my mind. I know you can do this, but you're going to have to be careful. Because if you mess up a sign along the way, you're obviously going to get the wrong answer. So we really have to work carefully. So, here we go. What's the first thing you think we ought to do when we have to solve this equation?
Distribute.
So, I hear some FOILing. I hear some distributing.
I like distribute.
Gotta do both. Gotta do it all. So here we go. X squared minus 4x squared minus 12x plus 8. X squared, outside, inside, left. So step one is make sure that you have distributed correctly, foiled correctly, and all that. All right, now what? Just fixing my attendance.
Add the like terms.
Yep. Now we are going to clean up each side individually. So negative 3x squared minus 12x plus 8. And over here, negative x squared minus x minus 12. All of the like terms on each side are combined. All right? Now what?
You gotta set one side equal.
Get one side equal to 0, and it doesn't matter. Personally, I don't like that number to be negative. That's a quirk I have. So I'm going to add 3x squared. I'm going to add 12x. And I'm going to subtract 8. Now you can do that in individual steps if it's easier for you. I did it all at once, one at a time. So if I add 3x squared, that's 1. If I add 12x, that's gone. And if I subtract 8, that's gone. And now I have the 0. She said we need it. So what do I have?
2x squared plus 11x minus 10.
That's what I got, right there. All right, now what do you do with that?
Quadratic formula.
Quadratic formula. Once in a while, you might be able to factor it, but I'm not even going to try. I don't know if those are big numbers. So I'm just going to go ahead and use my quadratic formula. So x equals negative b plus or minus the square root of b squared, which is 121. You'll have a calculator, so if you need to do it on a calculator, you can. Minus 4 times a times c all over 2a. In fact, Chase, I'm going to text Marv. I haven't talked to him in a long time.
Okay.
All right, so what have I got under there now? We need to look carefully. What is that? $121. Now be careful, it's a negative and a negative, so it's actually going to become a plus. And it's going to be a plus 160. So I have 281. I believe is prime.
Yeah.
Can't think of anything that goes into 281. So we got lucky, that's our answer. A lot of work there, a lot of places to make mistakes, so be careful. But do we all know how to do it?
Yep.
All right. Now we're gonna do our domain questions. Before I start these, let's do a quick review of our rules. Who remembers, you can look on your notes, what are our domain rules? There's two of them. What are they?
Whatever's under the radical, it should be greater than or equal to 0.
So, if it's whatever's under radical,
Is that equal?
is greater than or equal to
0.
0.
And then the denominator can't be 0.
The denominator, whatever's in the denominator, it cannot be 0. If you know those two things, you cannot miss these problems. So here we go, let's look at the first one, 2a. Does it have a denominator? No, but it has a radical. And whatever is under the radical, which is 4 minus x, or 4 plus x, sorry, 4 plus x, has to be greater than or equal to 0. So I solve it. So x has to be greater than or equal to -4. And when I write my answer, I'll have a bracket and an infinity, because this looks like this. You don't have to graph it, but sometimes if you graph it, it helps you see the interval. Okay, easy peasy. What about B?
Can't you factor out 3?
You can, but remember, we're talking domain here. We're not solving it or simplifying it. We just want to know what's the domain. So we're focused on those two rules. You could factor out a 3, absolutely. But that doesn't have anything to do with domain. Negative infinity to positive infinity. Why?
Wow.
Because what are the red flags? Denominator, radical. If you don't have a denominator and you don't have a radical, then guess what?
You can't do it.
No, you don't have any issues. It's all real numbers. There's nothing to solve. So if there's no denominator and no radical, this is your domain. All right, what about C? It does not have a radical, but it does have a denominator.
So,
And Zion told us that the denominator cannot be 0.
Add the 3.
So I'll add the 3, I'll solve that. So I'll add the 3. And there is your domain. We talked about yesterday, if you want to write that as an interval, you can, but it's a little clunky, and the or equal to, or the not equal to's, the not equal to's, I don't care if you write them as intervals or not. All right, the last one. Uh-oh, double trouble. What do we have in the last one?
you got a radical and a denominator.
Exactly. So the radical says x plus 1 is greater than or equal to 0,
Yeah.
which means solve it. X is greater than or equal to -1. And that's part of my answer. I'm not done yet,
Could,
because I also have a denominator,
yeah.
and the denominator cannot equal 0.
No. So you have 4
So I'm going to solve it,
Divide by 2.
and x cannot equal 2.
How would you write that again?
Just like that.
Oh.
Remember, if they have one of these in them, you don't need to do another rule. It would look like this. We're bigger than -1, but we're not 2. So it would be -1 to 2, or 2 to infinity. That would be the.
So a radical would be the greater than or equal to, right?
Dude. It's your rule.
Oh.
Yeah.
I was just trying to put
Yeah.
it together.
Learn the rule.
Yeah.
If you follow those 2 rules, you can't be wrong. All right, put that away. Tomorrow we will have a quiz that will look like this. What? What do you mean? Because you got this right now. So if you do that, you have to do it like this. All right, which is fine. I said if it has this in it, you don't need to mess with that. All right, let's get our notes out. We are back on page 9.
Is this practice supposed to go to campus? Is it on campus?
I have no idea.
Well, if it isn't, you want me to email you? I was asking you to put it on there.
I don't know that I'm gonna put it on there.
Okay,
If you wanna take a picture of this when you can.
okay,
But quite honestly, we got notes at home that have the same problems, okay? So you can, by the time I got it on the campus, you'd be in it anyhow. So, if you feel like you need more practice, always take a picture of it before we start it. Okay, it's right there if you want to take a picture. All right, we are ready for 9E. Or not 9E, page 9, lettering. And I told you yesterday, I think, that this was gonna get exciting. This one is exciting. All right? Take a look at that problem. What just pops out at you to do? Factor. How would the top factor?
X minus 1
Plus
X.
1 minus 1, the difference of squares. All right, how about the bottom? How will it factor?
Plus 5 minus 5.
Plus 5 what?
Minus 1.
All right, plus 5 minus 1. Now, what do we notice about this? You can cancel. All right. When you cancel, you're going to have a hole in your problem. Now remember, we're working toward graphing. When we cancel, we're going to have a hole in our problem. We're going to have a hole along with our vertical asymptote. Now let's do that first. Your problem now looks like this. Because you canceled, that is now your problem. Would you agree?
Yep.
Now where is the vertical asymptote? Think about it yesterday.
-1 and -5.
Now be careful. This is the only thing I have in the denominator. And vertical asymptotes come from the denominator. So the vertical asymptote is x equals -5. Because why? That can't be 0. Right? And what would make it 0? -5?
Yeah.
X can't be -5. That's your vertical asymptote. Vertical asymptotes are cannot be. So here here is my problem now. I only have one vertical asymptote, because they come from the denominator. X can't be negative 5. Now what about the whole? Well, the whole is another kind of discontinuity, and it comes from what canceled out. What canceled out here? X equals what?
1.
X equals 1. X equals 1. Remember, what's our general rule? If we take a number out of a parentheses or put a number into a parentheses, it changes? Just like this became negative 5, that's going to become positive 1. So the hole is literally a hole in the graph, an open dot in the graph. It is a point. The X comes from what you cancel. Any guesses how we'll get the Y? Plug it in right here. So if X is 1, what do I get? 1 plus 1, 1 plus 5, I get 1/3. So when you graph this one, this is problem E, when you graph it, you're going to have your vertical asymptote at negative 5, just like that. X equals negative 5. Count over negative 5 and draw a vertical line. And then you're going to have an open dot in your picture at the point 1, comma 1/3. Okay. All right. Recap. Where do vertical asymptotes come from? Denominator. Vertical asymptotes come from the denominator. Where do holes come from? Whatever cancels out. If you don't cancel, you don't have a hole. All right, let's try the next one. What do you think we'll do here first?
Factor.
I would factor. How does anything factor, top or bottom? What do you think?
Plus 4
What?
X plus 4 and
X plus 4 and,
X plus 5.
yep. That's your numerator. How about our denominator?
Minus 4 plus 4.
X plus 4, X minus 4. Now your little heart is leaping for joy because those cancel. So our problem is really just that. Where is my vertical asymptote? I'm finding my vertical asymptote. Where is it? X equals 4.
Yeah.
So 1, 2, 3, 4. X equals 4. That's my vertical asymptote. Where do vertical asymptotes come from? The denominator. Smoke?
Why is it positive?
Because X minus 4 cannot be 0, so X cannot be 4. Remember, Smoke, we talked about it. If you take a number out of a parentheses, it changes every time. Now, what about a hole? Because I canceled, I know I'm going to have a hole. Where will the hole be? What canceled out? Not 4, negative 4, right? It's in the parentheses. Negative 4. How do I find the y coordinate?
You plug it in.
Plug it in right here. Plug it in over here. So negative 4 plus 5 is 1. And negative 4 minus 4 is negative 8. So we have a hole. Negative 4, negative 8. 1, 8. open dot in your picture. Oh my goodness. Look at the next one.
Can't get much better.
What are your thoughts about this one?
You gotta, separate it.
Factor by grouping on the
Yeah.
bottom. So Brian says down here, we're gonna factor by grouping. So x squared, x minus 4. Wait a minute, what can I take out of here?
On
Negative 1, x minus 4. Now that's just the bottom, I'm just working on the bottom now. So there's my common factor, x squared minus 1, and then you notice anything? X squared minus 1 is,
Minus 1 plus 1.
yep. So my denominator is x minus 4, x plus 1, x minus 1. Everything I've done so far has been in the denominator. Were you able to follow that? I did my grouping, had my common factor, and then factored that. So there's my denominator all factored out. Do you notice anything about the numerator? Mhm.
Negative 1
Like that?
is, yeah,
Hmm,
negative.
what's wrong with that?
you can cancel the 1.
No, I'm not canceling yet because I haven't factored correctly. Won't this give me a positive 5? Won't that give me a positive 5?
Yeah.
So I need to make this the positive and this the negative. Now I can cancel. Only one thing, and I'm left with this. Tell me about my asymptotes. Where are my vertical asymptotes? At x equals 4 and x equals 1. Where do vertical asymptotes come from? The denominator. Now what about my whole? Where is it going to be? Well, what canceled? Where's my x that canceled? Negative 1. How do I find my y?
You add them up and, right?
Plug it in. So negative 1 minus 6, negative 1 minus 4, negative 1 minus 1. I plug in negative 1s for all of the x's. Someone left the code in here yesterday. Was it any people?
That's Wendell. That's
Huh?
Wendell.
Who's?
Wendell.
Linda? Right. Okay. What does that equal? Let's see, negative 7 over negative 5 times negative 2. Negative 7 over 10. So my whole is at negative 1, negative 7 over 10. what number 4 says. What do those directions say? Find the
Find the
horizontal and
Vertical asymptote.
vertical. Now, vertical is easy. We've been doing that. Tell me where the vertical asymptote is there.
-3.
X equals -3, that's exactly right. Perfect. Now the horizontal asymptote is a little bit trickier to find. To find your horizontal asymptote, you look at your problem. Oh, by the way, does this one have any holes? No, because what's the only way you can have holes? You have to be able to cancel. If you can't cancel, then you won't have any holes. To find your horizontal asymptote, you box in just the x's. Forget about the rest of the problem, just box in the x's. So now I have 2x over x, which is 2. So your horizontal asymptote is at y equals 2. Now, everybody in the room knows what horizontal means, right? And when I draw a horizontal line, which axis is it going to hit? Y. So it's a y line. That's y equals 2. This one is x equals -3. That was pretty easy. Let's look at the next one. Anybody have an idea about the next one? Either vertical or horizontal?
You gotta factor them out first.
Yeah, we're in factor first. I've been in incredible picture. See that picture? 8 through 6. Alright, so yeah, let's factor what we can. So Brian, what do you think we can factor? This is your idea.
X minus 2, x plus 2.
On top. And,
And then x minus 3, x plus 3.
alright, and I'm gonna write the original problem over here on the side. Okay, so what does that tell me?
There's no holes.
No holes, nothing canceled,
And you have 2 asymptotes.
2 vertical asymptotes. A vertical asymptote at 3,
3,
and a vertical asymptote at
-3.
-3. Alright, everybody okay so far? Now, I need a horizontal asymptote. How did we do that in this problem? We ignored the numbers and just boxed in the x's?
Yeah.
What do you think I'm gonna box in? Here's my original problem. What do you think I'm gonna box in? The x squareds, yeah, I'm gonna box those in. And what does that equal? X squared over x squared?
1.
1. So I have a horizontal asymptote at y equals 1. Alright, you do C. Problem C. See if you can find a vertical asymptote, a horizontal asymptote, and a hole. Have you found any of it yet?
Yeah.
What'd you you find?
I got x equals 4 and y equals 1.
So a vertical asymptote at x equals 4 from the denominator, and a horizontal asymptote of y equals 1. What about a hole?
There's no rule.
No, because the only way you can get those, they're called removable discontinuities. The only way you can get one is to cancel, right? All right, how about D? D. And we're gonna do some harder ones.
You have to factor it out.
Don't be crazy or, scared, because there's fractions here. Where does the vertical asymptote come from? The denominator, right?
Yeah.
So 8x plus 6 can't be 0. Denominators can't be 0 ever. So if I solve that, I'll subtract 6 and divide. So what do I get? X equals negative 3/4. Here we are. X equals negative 3/4. Between 0 and negative 1. Drop in an asymptote. Now what about your vertical? I mean your horizontal, I'm sorry, your horizontal.
Would it be 3 over 8?
Mm-hmm. It absolutely would be y equals 3/8. Because you have 3x over 8x.
For the denominator, it's negative 3 over 4.
Yeah, because you subtract 6 and divide by 8.
Why isn't it positive 3/4 from the vertical? Asymptote?
Why isn't it positive 3/4?
Yeah.
Why would it be? What are you thinking? Because this is like a parentheses. It's always gonna be opposite. Okay, always. So to find your asymptote, set it equal to 0 and solve it. And whatever comes out, that's what it is.
Okay.
Okay? Asymptote, or denominators cannot be 0. So my denominator cannot be 0. So I subtract 6 and divide by 8. All right, look at the next problem. I think you won't have any trouble, I hope, with the vertical asymptotes. Anybody want to take a guess about the vertical asymptotes?
2 and negative 2.
Very good, Brian. Where do vertical asymptotes come from? Denominator. Does that factor?
Yeah.
So we have 3x plus 1 over x minus 2, x plus 2. Right there are your vertical asymptotes. Negative 2 and positive 2. Now, the horizontal is different. What do you notice about this problem that's different from all the others that we've done here?
It's
Ryan?
x squared and a 3x, so I don't really know how to.
So in the other ones, we had like x over x,
Yeah.
and we had one where it was x squared over x squared. But this one, they don't match.
So it'd be 1/2.
When the powers don't match, so you know you gotta do some boxing. But you can't box an x and an x squared. You can only box the highest power. The highest power is X squared. I don't have one in the numerator, so I have to physically put one in the numerator. So if you are missing the power you need, I need an X squared to match this one. My powers have to match. And they gotta match the largest, which is X squared. I don't have an X squared up there, so I'm gonna stick it in. So now I have 0x squared plus 3x plus 1. Now, can I box these in? Yes. And what is 0 divided by 1?
0.
0. So where is your horizontal asymptote?
0.
Y equals 0. One more thing, piece of information I will give you to know or not know. If the power on top is smaller, so this was x to the first, that's x squared, so the power on top is smaller. If the power on top is smaller, the horizontal asymptote will always be y equals 0. Always. If the power on top is smaller. So when I look at letter F, is the power on top smaller? Yes. You know what I mean by power? It's x to the first. On top is x to the first. What's
Yeah.
on the bottom?
X squared.
X squared. That's bigger. The power on top is smaller. When the power on top is smaller, the horizontal asymptote will be 0. Always. So for problem F, the horizontal asymptote is y equals 0. What about the vertical asymptotes for problem F?
X
Factor.
minus 3, x minus 1.
No,
No.
because 3 and 1 don't multiply to 4, so we need 4 and 1.
Yeah.
So I have verticals at negative 4, x equals, and at positive 1. And y is my horizontal at 0, because I don't have an x squared on the top. One more time. If the powers match, like they did a minute ago, if the powers match, you're gonna box them in, and it's 8, 6 or whatever. If they don't match, and the one on top is smaller, it will always be 0. What happens if the one on top is bigger? Let's look at problem G. First of all, where's my vertical asymptote?
X equals 2.
X equals 2. I hope you've all got this down like Brian does. He's got this figured out. Now, what about my horizontal? I have to box in the biggest power. What's my biggest power? X squared. I have one x squared on the top, but I have no x squareds on the bottom.
Yeah.
So now when I box them in, I get 1 over 0, which is
0.
no,
Oh, undefined.
none, undefined. So there is no horizontal asymptote. If the power on top is smaller, the horizontal asymptote is at 0. If the power on top is bigger, there's a 1. There's no horizontal asymptote. All right, one more. Are you okay with me just factoring that? We're getting close on time. Are you okay with me just factoring that?
Yes.
Now, there's two parentheses, but they're the same. Fine. You know I got your mom on speed dial, right? Yeah. So here we go. They're the same, so there's only one vertical asymptote. It's at x equals 2. What about a horizontal asymptote? I've got 3x cubed over x squared.
Yep.
Can't do that, all right? They gotta match. So make them match. Put an x cubed on the bottom. It would have to be a 0. What about 3 over 0? Can't do it. So no horizontal asymptote. All right. That finishes 1.2. So that homework will be due on Friday. Now, to get ready for tomorrow, I'm going to hand these around. I need you to take 12, and then pass them back. All right? So take 12, pass them back. Talk about what this is for. Take 12, pass them on. All right, let's go. Take 12. Go. Everybody needs 12. If you've got your 12, pass them to somebody who doesn't have any yet. These are going to be your BFF flashcards. Your basic family of functions. There are 12 functions that you are responsible for knowing their name, their equation, and their shape. So we're going to build these flashcards together in class, and these are every time your Bible. So you can paper clip them together, you can put them in a baggie. I don't care what you do with them, but it's going to behoove you to have them. So don't lose them, don't throw them away, because you're going to wish you had them. And once we do our first set, we don't think anymore. So hang on to them. Everybody's got them? If you counted wrong, I do have more. So if you counted mine's got 12.
You're not putting up BFS right here.
Those are BFF problems. We're going to do the BFF. Now, the other day, when I handed out the materials, I had you grab 3 packets, remember? One was your notes, one was your homework, and one was the BFF sheet. So I need you to get out your BFF sheet. Do I have all my extra cards? So we're getting out our BFF sheet. Basic Alright. You will notice that on this BFF packet, there are 12 functions. You have 12 flashcards, right? So we are going to go through these, not today, starting tomorrow, And you are, I'm going to tell you what to put on your flashcard and what you need to know. The good news is, you do not need to know all of this stuff for every function. Alright? That is not for us, that's for someone else. You will need to know certain things, but I will tell you what those things are. You will study your flashcards, and then you'll have a quiz. And it's just plain and simple memorization. Have you learned your flashcards? Okay? So the three things you're going to put on your flashcards, and we'll do it together in class. We'll do it together in class. So we're going to put a name, or not our name. We're going to put the name of the function, the equation of the function, and a picture of the function. And how you design your flashcards is up to you. Some kids put the name and the equation on the front, the picture on the back, whatever. It doesn't matter to me how you design it. Those are the three things you're going to know for every flashcard. Okay? All right, I'm going to stop there because we don't really have time to start. But that is exactly what we will begin